Screen is visible.
Yes, sir.
Now KCL. For this, I am going to consider this circuit. For what I consider the circuit or that impedance in series with voltage source. For KCL, the admittance in parallel with current source. ISK. This is YK. The total VK. IK plus minus. This is a circuit diagram. If the branch K, this is a branch K, contains an input current ISK, this is an input current source ISK, and YK, YK is the admittance, ISK is the input current source, then I can write IK equals to YK VK, then minus ISK. YK is nothing but 1 by ZK, correct? 1 by ZK. Okay, so I can write IK equals to YK VK minus ISK. Here also up to B branches. This is the kth branch I am writing. You can simply see here, this equation is nothing but IK equals to YK VK minus ISK is nothing but the KCL equation at this first node, that the positive sign is there, that node I am writing one KCL equation. Okay, here YK is the admittance, ZK is the impedance. I can write admittance is equals to 1 by impedance. In matrix form, how am I going to write? IB equals to YIB PB minus IS. Here YB is the branch admittance matrix. Okay, and VB is the branch voltages. IS is the source current matrix. Now I can write A into IB equals to, already we seen in the KCL equation that A IB equals to 0 for KCL. For KVL, B into 0. For KCL, A into IB equals to 0. Okay. B, just I am going to insert here YB IB, YB VB minus IS equals to 0. Then it's become as A YB VB equal to A IS. Then VB, I know VB equal to A transpose VN, node voltages. Okay, this one we have to remember. There B transpose IL, IB equals to, here VP equal to A transpose VN. We need to remember this one for writing the KCL equation for networks. VB equals to A transpose VN, VN is the node voltages, A is the incident matrix, VB is the branch voltages. For writing KCL. In KVL, we need to remember IB is equals to B transpose IL. IL is the loop current. Okay. B is the tie-set matrix. IB is the branch currents. Okay. If I am going to insert this one there, A equal to YB, A transpose Vn equals to A into IS. Okay. Then Y into Vn equal to I. Correct? Where Y is, where Y equals to A YB A transpose and I equals to A into IS. Where A is my incident matrix. A transpose is my transpose of that impedance matrix. YB is my admittance matrix. Yes? Okay. Now, the matrix Y is called as admittance matrix This is admittance matrix. Okay. Now this KCL equation, where while deriving that KCL equation, we introduced cut set also, Q. Okay. Now we can write the KCL equation as, see here. Okay. See, Q equal to, if you people attended the last class, in the sense, for basic KCL equations, we have introduced this cut set matrix. Okay. IB equal to 0. Okay, then Q equal to IB, we know, VB IB, YB VB minus VS equals to 0. So this is IS. Yes, then Q YB VB equal to Q IS. Then we know VB equal to Q transpose VT, twig matrix. VT is a twig matrix. Simply with this one, VIB Q transpose VT equal to Q into IS. Okay, why VT equal to I? So I can write Y equals to Q YB Q transpose I equals to Q IS. There are two KCL equations we can get. Okay, where A is the incident, here Q is the cut set matrix, incident matrix and cut set matrix. Okay, I equals to QIS, I equal to EIS. For this matrix, we are going to get like this. Fine. Now what I am going to do, I am going to consider one voltage source in series with this admittance. I can replace this YK with ZK. Then I am going to write the KCL equation for that circuit. Okay. Okay. This is the circuit. See, once you solve by your own, derive by your own, then you'll get to know how these derivations, that is A YB A transpose and Q YB Q transpose, we will get to know. Then here ISK, here VSK, then this is ZK plus minus. Okay, here the one voltage source is in series with the impedance and the current source in parallel with the combination of voltage source and impedance. Okay, now I can write, we know that inverse of the impedance will be the admittance. I can simply write phi k equals to 1 by zk. Correct? For this circuit, I'll write my equation as ik equal to yk vk plus yk vsk minus isk. If this is not there, then yk is given, then my equation will be vk equal to zk ik plus zk isk minus vsk. Now sorry, this one, what do you call this one, ik equal to yk vk minus isk, where only one impedance, one current source is there. Ik equal to yk vk minus isk. For this, if one voltage source in series with the admittance impedance, then I can write yk equal to 1 by zk, ik equals to yk vk plus yk vsk minus isk. Okay, if I am going to write this one in a matrix form, ib yb vb plus yb vb minus is. Okay, my KCL equations will be given by, I a equal to a into ib equals to 0. Okay, a equals to, I can insert this one. Okay, yb vb plus yb vs minus is equals to 0. If I simplify this one, I will get A YB VB equals to AIS minus AYB VS. VB equals to A transpose Vn. N is the node voltage. Okay, node voltage matrix. Okay, then you know A YB A transpose. If I'm going to insert this one Vn, then AIS minus A YB Vs. Then I can write Y Vn equals to AIS minus A VB Vs, where Y is A YB A transpose. Okay, is the node admittance matrix. I can write this Y is node admittance matrix. Okay, this is a generalized KCL equation in terms of incident matrix. Now if I'm going to write that equation in terms of F cut set, same here AIB for incident. Now QIB equals to 0, Q equals to I want to insert this IB, YB VB plus YB VS minus IS equals to 0. If I am going to simplify this one, Q YB VB equals to Q IS minus Q YB VS. VB equals to Q transpose VT. We know this one, right? Okay. Now Q equals to Q into YB Q transpose VT Q IS minus Q YB VS. Then Y Vt equals to Q IS minus Q YB Vs. Y is the node admittance matrix. Y is the node admittance matrix. Okay, we can see from here and from here the equations are same, but here incident matrix for incident fundamental this incident matrix, and for this one is for fundamental cut set matrix. These are the KCL equations. Okay, here one thing to remember, you know that first, see, we need to remember this. Okay, first one, for KVL IB equals to B transpose IL. Okay, then VB equals to VB. Yeah, we know for KVL IB equal to B transpose IL, and for KVL only VB equals to, yes, tell me. IB equal to B transpose IL. While deriving the KVL, we come up with this one. We came across this IB equal to B transpose IL, right? Then VB equals to
A transpose Vn.
Yeah. Equals to A terms of Vn. Yes. Okay, then this one Vb equals to Q transfer Vt. These three things we need to remember. Okay, now how we are going to write these equations for given network? This is a network given. First, we know for KVL, we know that BBB equals to 0. VB equals to 0. For KCL, we know that A IB equals to 0. Start with this. First, start with the network equations. Okay, then transform that into. Here I will show you. First step, network will be given. See everyone, please do see this one. This is the whole conclusion. Okay. Okay. Next, write the equations for that network. Then write this equations in matrix form. Okay. Then for KVL, B equal to VB equal to 0. For KCL, A equal to IB equal to 0. Then simplify that. From here matrix form, we are going to get some VB. For KVL, KC, we are going to get IB. Okay. If something will be there here, something will be there, then KVL B equal to VB equal to 0, KCL A equal to IB equal to 0. Okay. Then we need to insert this VB here. Okay. Then this one, IB B transpose IL, IB B transpose equal to IL. Then VB A transpose VN, VB A transpose VN, VB Q transpose VT. This is for F cut set. This is for incident. Okay. Okay, this is a conclusion for K.